For number 7, there's another profit statement. A guy gets $15 a customer if it serves 1,000 customers or less. If it serves over 1,000 customers, the profit decreases per customer for each customer over 1,000. How many customers will maximize the profit? So this is like the very first one, where we start with $15 and we take off a cent for everyone over 1,000 people. And then we multiply that by how many people. So there's your equation. That's the profit. So P equals 15 minus 0.01x plus 10 times x. So P equals 25x minus 0.01x squared. P prime would be 25 minus 0.02x, and you set that equal to 0. So 25 equals 0.02x, so x is 1,250. So we have the same negative slope, positive negatives. This will maximize it. So 1,250 customers will maximize profit. Going to the next, number 8. Paper here, we have Dobbs Hotel. Provide a dinner party for a minimum of 100 customers. Then they'll refund 25 cents for every couple over 100. So how many couples will maximize the hotel's revenue? So in this case, I'm going to have X be the number of customers over 100. So we had 100 and we had $50 each, and so now we'll have 100 plus X number of customers, and it's 50 minus 0.25x. That's equal to P. So multiplying that out, 5,000 minus 25x plus 50x minus 0.25x squared equals P. So 5,000 plus 25x minus 0.25x squared equals P. Now take the derivative. P prime is equal to 25 minus 0.5x. Set that equal to 0. 25 equals 0.5x, so x equals 50. Now this is 50 more. So it asks how many couples will maximize, so you have to add it to the original, so 150 couples would be the answer for number 8. Let's do number 9. Oh, it's the poster one. All right, so you're given a poster, and it has this area inside that has the writing. So we'll call that XY. And then it adds margins. So the margins are the Y. If this is a new Y, these are 4. So plus 4 plus 4. So this is Y plus 8. And the top, the sides are, let's see, how much are the sides? And the bottom, at the top and bottom, and 2 on the sides. So this is x plus 4, because each of these would be 2 plus 2. All right, so we have y plus 8 and x plus 4 being the outer and xy being the inner. And they tell you xy is equal to 50 inches squared. And so we want to maximize the whole thing, so our maximization statement would be x plus 4, y plus 8. But now I need to have only one variable. So I'm going to replace y. Let's see, y would equal 50 over x, so I get x plus 4 times 50 over x plus 8. And that's going to be my area. And so that would be, multiplying it out, 50 plus 8x plus 200 over x, right, plus 32. So that's equal to the area. The area is equal to 82 plus 8x plus 200 over x. So a prime now would be 8 minus 200 over x squared. Set that equal to 0. So this would be 8x squared minus 200 equals 0. So 8x squared equals 200. X squared would be 25, so x would be 5. And if you put that into a sign chart based on this, you would have, starting at 1, it would be 8 minus 200, so it would be negative, positive. So this would definitely be a minimum. And so you would have, now they want the outer area. So they just want the area. Find the overall dimensions. Okay, so overall dimensions would be the outer. So that would be x plus 4, so 5 plus 4. And then y is 50 over 5, so 10. Y is 10. Sorry, so x equals 5, y equals 10. So it would be 10 plus 8, so 9 inches by 18 inches. So 9 by 18. All right, and I'll do the last problem on a separate video.